Can you hear me okay? Awesome. Hi, my name is Patrick Kerwin, and I am a master's student studying GIS at the University of Arizona. And today I'm going to be talking about Earth observations for disasters. So remote sensing is so incredible, just endless possibilities of how to be used. And one of the most impactful uses is for disaster response and really understanding where the impacts are being heaviest felt and what is being affected. So I came across this topic as an intern with NASA's Disaster Response Coordination System, which is housed in the disasters program. And the big goal of the DRCS is to connect NASA science and data with disaster response organizations and emergency managers. So today I'm going to be sharing a few examples of some of the data that the DRCS has connected for disasters, and then showing a few experimental explorations trying to take that data a little bit further and just see what else we can do with it in answering those questions. So we're going to have 3 quick case studies. Bangladesh, some flooding in Bangladesh, an extreme heat event in Houston, Texas in 2024, and then Hurricane Helene. So jumping right in, let's start with some flooding in Bangladesh. So in August of 2024, Bangladesh experienced a pretty severe rainfall and flooding event, particularly in the more northeastern portion of the country, which is what we're looking at. So NASA, the DRCS, provided dynamic surface water extent maps derived from harmonized Landsat and Sentinel-2 data. And this is what that data looks like at a pretty simple state. So we have the flood water in red and the existing water in blue. And we can zoom in a little bit more and sort of see that riverine flooding a little bit better, some flooding more in the western portion. And this is great. We can get a good overview. We can sort of understand where the flooding is, and that's a good start. But we can take it a little bit further. So a pretty simple but important step, just intersecting it and with some sort of demographic boundary. So in this case, we have it by Union Council, which is the smallest sub-district in Bangladesh. And so now we have a lot more information. We have flood coverage per union district, and so we can understand a little bit more about who and what is in those areas. So we can do a little bit more. So we're going to jump now to Houston, Texas. So this zooms into Houston. In May of 2024, Houston was hit with a derecho, a series of really strong storms. And this caused flooding and it had really strong winds that knocked out a lot of power. So the DRCS provided black marble imagery. So this is a nighttime lights imagery product derived from VIIRS on the NASA NOAA Suomi NPP satellite. And this is what that looks like. So this is a black marble HD product. And this shows Houston in April of 2024. So this is before the event. And now we can go to immediately following the event, and we can sort of see where a lot of those blackouts occurred. So we have a big change in that luminosity. And we can keep going through this week immediately following and start to see some of the power come back on. And then by the end of the week, a lot of it has returned. So we're going to do that first important step and merge it with a demographic boundary. We can show some neighborhoods. So this is just to see a little bit more clearly. And then we can go to that demographic boundary. So this is power outage likelihood by census tract. So now we have that first step. We have a little bit more information about who is in the areas that might be experiencing power outages. And we're going to keep going. So now this is a social vulnerability index. So this is data from the CDC, and it shows census tracts and shows the potential for higher environmental and social risks in those areas. Then we can merge those into a bivariate map. So now we have both in the same place. We have both factors. We have social vulnerability in the blue, power outage likelihood in the red, and then we can the dark purple is showing areas that have increased risk for both social vulnerability and for power outages. So this is a great tool that the emergency managers can put into their toolbox and give a little bit more context into where they should and could provide more resources. So now we're going to jump to Hurricane Helene. So this is an image from the ISS for Hurricane Helene. I like it because I think it just shows the scale of the storm. This was a massive storm. It affected millions of people. It's still affecting people today. And the DRCS put out a number of products, but we're going to stick with black marble. So this is still the nighttime imagery product. And this is showing across the southeast. So I'm going to click through again, like the previous event, but it's going to be a little bit harder to see just because of cloud cover. But I would start by focusing right around this area. So this is around Augusta, Georgia. So the event starts, we can sort of see the lights disappear in some areas, and then just traveling through, and then now approaching sort of a week out, some of the light is returning. So again, we're going to start with that demographic boundary. So this time it's by zip code. So we have luminosity change or potential power outage by zip code in this area. And it's great to know where the people are. It's super important. Another really important thing to understand is the effects on critical infrastructure. So the next slides that I'm going to show are some examples of how this data could be used to sort of understand what is affected and where the damage might be worse, or at its worst state. So this first map shows fire and EMS stations in the area. So stations in red are in areas that have a higher likelihood of power outages. And I have a table here just because we have concrete examples of some stations that can be handed and put in the hands of emergency managers and to help them understand where they might need to allocate more resources. So moving on, this is transmission lines in the area. So transmission lines in the red are in areas of higher power outage likelihood. Lighter colors indicate less risk. Another tool that emergency managers can put away and use to help validate with other data sources as well. And then this last map shows cell tower locations. So the light blue color shows cell tower locations, and then the yellow to red pixels are areas that have cell towers and also potential power outage likelihoods. Another potential tool just to get a little bit more information on cell service lapses. So some takeaways. All this data is super valuable in providing information on people and critical infrastructure. It's important to note that it's all supplementary. So it wouldn't ever be the only information being used, but can be used to help validate with other data, and it's especially good at filling in areas where information is a little more scarce. So it's especially valuable in rural areas. And I just wanted to say a huge thank you to the DRCS, the coordinating office, Josh Barnes, Lauren Childs-Gleason, Carrie Roller, Katie Piccioni, Patrick Rea, to the whole disasters program, to our program manager, Dr. Shana McLean, and to AGU for putting this on. Thank you so much.